Yeah, and money to body problem rap, yo. I hope you enjoy. Yeah, 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 yeah. You got two bodies, ain't talking about your shawties. First you got body A, then you got body B. Held together with pulleys. They got two different masses with a string that's massless. Here's some quick info that you need to know. Gravity is 9.8 meters per second squared, that's right. And the force is mass times acceleration, yeah. And that ain't changing, yeah. Now that we got that out of the way, I got a little more to say. For this first question, they both pulled down. Better pay attention now, don't be a clown. First you take the massive A and times it by gravi-tay. Then you take the massive B and times it by gravity. Then you find which force is greater, now the other one's a hater. You take the greater force and minus the lesser force, of course. Get the net force from that. Do that right or I'll get the gat. Then you take A and B and add their mass. Then divide the net force by that real fast. So that's how you get acceleration of the first two body question. Now we got this next question, yo, it's slightly different though. When box is on a table and there's friction, it's measured by mu, also called coefficient of friction too. Better start the same way. Take the massive A and times it by gravity. Then you take the massive B and times it by gravity. Then take the force of the body on the table. Multiply it by mu if you're able. But if there is none, then next frictionless and you're already done. Gives you force of friction. Add that to your diction. Now subtract that from force of B down. You're in force total 10. Now divide that by the mass of B and A. You got acceleration, hooray. This final one is pretty tricky. It involves trigonometry, because box A is on an angle, so you have to use sine, cos, and tan, but not the kind of tan that's done in the sand. Thank you for that line, Megan. So you take the massive A, yep, times it by gravi-tay. Then you take the massive B and times it by gravity. Now it gets more crazy, so pay attention, don't be lazy. Now you're gonna wanna make a triangle. Yeah, with the right angle. Don't make it obtuse. Now make your force down the hypotenuse. Now put your angle at the top. Don't be a sloth. Then you do force of gravity on A times sine and your angle, yo. Then you get force parallel, though, which is how much A is pulling against B. Now we gotta find force normal for friction, my G. Now you do the same as before, but with cos this time. Do cos times your angle times gravity, and you'll be a dime. Now force normal is what you get, we're almost done. Now it's force normal times mu. Find the force of friction, that's all you do. Now force down by B minus force parallel of A. You get the force total E of B minus force friction E. Finally, last divide that by the mass of A and B. Get acceleration of this final question.